Hello, Algebra Tours. Today we're going to be talking about writing quadratic functions or quadratic equations given a description or given a graph. So what you're going to need is your notes, a pen or pencil, your notebook, and maybe a calculator if you want it. So you should have a half sheet as a foldable, and it should be labeled writing equations of quadratic functions. On the top, you should write the generic form in vertex form and the generic form for intercept form. So you should write on the top of your foldable, or even if you want to write it in your notebook by your foldable, make sure to write down the vertex form, which is f of x is equal to a times x minus h squared plus k, and intercept form is f of x is equal to a times x minus p times x minus q, where p and q are x-intercepts on the graph. All right, so we have 4 examples that we need to get through today, and number 1 is writing an equation for the parabola or the quadratic function given this graph. So in this graph, they give me the vertex point and the y-intercept. So because the graph gives me the vertex, I'm going to want to use the generic vertex form, which is y or f of x is equal to a times x minus h squared plus k. And just like we learned with absolute values and with lines, translated form tells me that the vertex is just h comma k. So if that's hard for you to see, let me write it in blue. So this vertex is h comma k, and so because our vertex is -2 comma -3, that means that our h is going to be -2 and our k is going to be -3. So we know y is equal to a times x minus a -2, which turns to positive, squared, all plus k, which in this case k is a -3. So in order for us to fully write a quadratic equation, we need to have h, here I'll circle it for you, we need to have h, k, and a filled out. So in order for our quadratic equation to be complete, we need to figure out what a is equal to. Well, a is the vertical stretch or shrink, and it's going to take a lot for me to just find that by finding multiple points on the graph. So we need to figure out what other information was given to us on this graph. So we already used the vertex, but we also were given the y-intercept, which is an ordered pair. And every ordered pair is written x comma y. So we can plug in this x value 0 and this y value 5 into our equation in order to solve for a, because we need a for our final equation for a quadratic equation. So let's do that. Let's plug in 0 comma 5 in for x and y into my equation. So we're going to change this y to a 5 is equal to a, because that's what we're solving for, times x is 0 plus 2 squared minus 3. So now we just need to solve for a, so let's do what's in parentheses first. 0 plus 2 is 2. That thing's getting squared. There's still an a in front of it, a -3 behind it. Bring down the left-handed side. Now we know that 2 squared is 4. It's still getting multiplied by an a. Minus 3, bring down the 5. We still need to get a alone, so now we just have a 2-step equation. Add 3 to both sides. 5 plus 3 is 8, which is equal to 4a. Divide by 4. 8 divided by 4 is 2, which means that my a, or my vertical stretch, is 2. So my final answer for my quadratic equation is going to be replacing a, h, and k. So we know that h is a -2, k is -3. Now we just need to replace a with 2. So my final equation is going to be y is equal to 2 times x plus 2 squared minus 3. That, ladies and gentlemen, is my final quadratic equation for number 1. All right, now we need to write an equation for the quadratic function of this graph given below. And this graph gives me 3 ordered pairs. It gives me an ordered pair just somewhere on the graph. It's not at the vertex, it's not at any key feature of the graph. And then they also give me this x-intercept and this x-intercept as ordered pairs. So because they gave me the x-intercepts and I don't know the vertex, and it's hard to tell what that vertex is down here, we're actually going to use the intercept form. So we should have written that down on the top of our foldable. So intercept form in its generic form is y is equal to a, that vertical stretch or shrink, times x minus p, which is one intercept, and then x minus q, which is another intercept. For whatever reason, they just decide to use the variables p and q just because we've always been using the letters towards the front of the alphabet, so why not use the letters towards the end of the alphabet? Okay, so we know that -3 is an intercept and 2 is an intercept. So it doesn't matter which one's p and which one's q, so I'm going to call -3p and 2q. So let's plug those into our function or our equation. So y is equal to a times x minus p, and in this case it's going to be minus a -3, which changes it to a positive, and then x minus q, which is 2. And just like when we did number 1 in vertex form, we still have to find what the vertical stretch or shrink is, or we need to figure out what a is. And each graph will never flat out give me, if you've been given a graph, it won't tell me, oh, a is equal to this number. We have to find that number from this other ordered pair that they gave me. So -2 is going to be my x that I'm plugging into the equation, and -4 is going to be my y that I'm plugging into the equation. So I'm going to plug in -4 for y is equal to a times x is a -2 plus 3 times x again, which is a -2 minus 2. So I plugged in this ordered pair in for y and in for x into that part of the equation. So now we just simplify. So -2 plus 3 is 1. -2 minus 2 is a -4. We still have an a out in front, and the left side we can't reduce, so let's bring down that -4 equal to a times 1 times -4. We're just multiplying that all out, so a times 1 times a -4 is just simply -4a. Bring down the left side, we have -4 is equal to -4a. Our last step for solving for a is dividing by -4. -4 divided by -4 is 1, so my a value is actually just 1. So back to our equation up here. We know a is 1 now, so our final quadratic equation is going to be y is equal to, if you want to write the 1 there for a, you can, times x plus 3 in parentheses times x minus 2 in parentheses. And that is my final equation for number 2. All right, example number 3. We need to write the quadratic equation given these key features in words. So we're not given a graph this time, we're just given the vertex at the point 2, 1, and we know that the graph also passes through the point 0, 4. So the fact that they gave me the vertex tells me that I want to use the vertex form. So y is equal to a times x minus h squared plus k. So every single vertex is h comma k. So I know that h is 2 and k is 1. So we know that y is equal to a times x minus 2 squared plus 1. But now we always have to find the a because they didn't give me a, they just gave me a simple point, which we know represents the variables x comma y. So we have to find what a is by plugging in 0 for x and 4 for y. So let's replace y with a 4 equal to a, because that's what we're solving for. Replace x with 0 minus 2 squared plus 1. Okay, so now just simplify. 4 is equal to a. Simplify 0 minus 2, that's a negative 2 squared plus 1. A negative 2 quantity squared is telling me that it's a negative 2 times a negative 2, which is just 4, and that's getting multiplied by a. Bring down the plus 1, bring down the left side. 4 is equal to 4a plus 1. Subtract 1 from both sides. 4 minus 1 is 3, equal to 4a. Now we have to get a alone, so we have to divide by 4. So this can cancel to 1. And we know that a is equal to 3/4. So we can plug 3/4 in for a into that part of our equation. And so our final equation is going to be y is equal to 3/4 times x minus 2, because that's my h in my vertex, squared, plus 1. So my final equation is that equation in purple, y is equal to 3/4 times x minus 2 squared plus 1. And last but not least, we have another situation given in words, and this time instead of giving us the vertex, they gave me the x-intercepts, which means that I want to use the intercept form. So y is equal to a times x minus p times x minus q, where p and q are x-intercepts. So I'm just going to pick p to be a negative 2 and q to be 1. You can pick p to be 1 and q to be negative 2. That's okay. And we also know that it passes through the point negative 1, negative 4. Well, let's plug in p and q into our equation. So we have y is equal to a times x minus a negative 2, because that's what p was, so that changes to a positive 2, times x minus q, which is 1. So again, we were not given what the vertical stretch or shrink was, so we just have to plug in negative 1 for x and negative 4 for y from this ordered pair. Okay, so y is negative 4, so we're going to say negative 4 is equal to a times x is a negative 1, so we're going to replace each x with a negative 1, so negative 1 plus 2 times negative 1 minus 1. Negative 1 plus 2 is 1. Negative 1 minus 1 is a negative 2. Bring down the rest of our equation. On this right-hand side, we're just multiplying three things together. So a times 1 times a negative 2 is just negative 2a. We have a negative 4 on the left-hand side. To get a alone, we have to divide by negative 2. That cancels to 1. So a is equal to a negative 4 divided by 2, which is a positive 2. So that means that we can replace this a with what we found, which was 2. So my final equation is going to be y is equal to 2 times x plus 2 times x minus 1. And that's my final equation in intercept form. I want to thank you all for taking good notes. Let's make sure we get all of this written down on our foldable and get our foldable into our notebook. And I shall see you soon.